Hello, my name is Taylor Crumpton, and today we're going to do this calculus problem. A fence must be built to enclose a rectangular area of 20,000 feet squared. Fencing material costs $3 per foot on two sides and $6 per foot on the other two sides. Find the cost of the least expensive fence. So, first off, we're going to draw a rectangular fence. So we have a visual aid of our problem. So we're going to have our two x's facing north and south, and our two y's facing east and west. Now that we have a visual, we know that 2 feet of fencing at $3 per foot are needed for the two sides facing north, and 2 y feet at $6 per foot for the other two sides. So we're going to determine our cost, C, for the fence. Now C is going to be 6x plus 12y, being that there's 4 sides of the fence. Now that we have cost, we're going to find all the values of x and y that make C as small as possible. First, express y in terms of x using the formula for the area. So we all know our formula for area, which is xy equals A, or area. And we also need to find what y equals. So y, to take x out, is going to equal 20,000 over x. Now the 20,000 comes from taking out the y. So now we need to express C in terms of a single variable. So C equals 6x plus 240,000 over x. Okay, let's erase some of this stuff we have here. Now, since x is a length, it is positive. Hence, it's the domain, which is the cost of the function. And the open interval for the cost of our function, being a positive number, is going to be 0, infinity. Oh, that's a bad infinity. Since the interval is an open interval, we only look at the critical numbers. So we need to find our derivative of C. So C equals 6x plus 240,000 over x. So our critical number, I'm going to write right here, is going to be 6 minus 240,000 over x squared. Okay, so we have our derivative. I'm going to erase this right here. And once we have our derivative, we're going to solve this problem for 0 in order to find x. So let's write 0 equals 6 minus 240,000 over x squared. So first let's flip these signs, make it a little easier. We're going to start at negative 40,000 plus, let's just erase this, 6x squared. So we're going to equals 0. Now we're going to divide the 6x squared out. So we're going to, we're going to minus this 6x squared. So that goes to the other side. So negative 240,000. Let's erase that. That looks really ugly. Negative 240,000 equals negative 6x squared. So we're about halfway there, and let's divide both sides by negative 6, which is going to equal x squared equals 40,000. As you see, both sides become positive, being a negative and a negative. And when you get the square root of 40,000, x is going to equal 200. Now, x also equals negative 200, but the only critical number in your domain is positive 200. So, now that the function c has a minimum at x equals 200, by using the second derivative test and the critical point theorem. So, let's erase this stuff. Now we know how we got x. So we're going to write x equals 200, and we don't know why. So the second derivative test states that if the f to the second derivative is greater than 0, it has a local minimum. If f to the second derivative is less than 0, it has a local max, and if it equals 0, the test gives no information. So let's find the derivative to the second of c. So if you recall the first derivative of c, it is 6 minus 240,000 over x squared. So to get the second derivative, we're going to take that 6 out and multiply to get 480,000 over x cubed. Now we need to evaluate the second derivative of c to the critical number at x, which is 200. So derivative of 200 equals 480,000 over 200 cubed. And when we put that in our calculator, ugly, we're going to end up at c to the second derivative of 200 equaling 3 over 50. Now, since the second derivative of 200 is greater than 0, we know that c has a local minimum at x equals 200. So x is a minimum. Okay. Almost there, folks. So we use the critical point theorem to show that the function c has an absolute minimum at x equals 200. The critical point theorem supposes that a function f is continuous on an interval 1 and that f has exactly one critical number on the interval. If f has a local minimum at x equals c, then this local minimum is the absolute minimum of f on the interval 1. Since c has a local minimum at x equals 200, then this local minimum is the absolute minimum of c on the interval 0 to infinity. So now that we know this information, we have our minimum, our open interval 0 to infinity. We're going to find the value of y. So y equals 20,000 over x. And thankfully we know x is a pretty easy problem. Y equals 20,000 over 200, which equals 100. So we now know that y equals 100. Now that we have both of our variables, we're going to determine the cost of the least expensive fence. So c equals 6x plus 12y. c equals 6 times 200 plus 12 times 100. And let's go ahead and put that in our calculator to make sure we're correct. And the answer is 2,400. So now we know x and y at 200 and 100 for each sides of the fence, and the cost of our least expensive fence is going to be $2,400. I hope you learned something today, and thanks.